1:30. I think we'll get started.
You may have noticed that we're simulcasting this to a bunch of people in Silicon Valley, and occasionally messages pop up, so let me know if something pops up like that, because I typically won't see it. Okay, welcome to Introduction to Human-Computer Interaction for Technology Executives. I've been running this course about 10 years now. We have continually tried to improve it every year, and we always have way more people at the first lecture than will fit. There's lots of seats over in the front. So I put the first lecture in this room. We have over 100 people registered for the course. Our main room seats only 65. I expect that that will probably be the number of people that are in the course after the first homework assignment. But if you actually quit now, that would be helpful if you're not going to take it. But my goal today is to try and convince everyone to stay in the course. So that's, what did the pop-up just say? Anybody? Huh? The pop-up said the slides are not visible. You got it? Okay. So today's Halloween. So we have leftover Halloween candy. Everybody take two, be polite. We'll start here and you can go across. These are not identical, but they're pretty similar, so maybe I'll put this one in the back. We'll let our handy videographer start off. Sorry for the Silicon Valley people, I can't really get you any candy. Okay. So this course has 3 different numbers. They're all identical. It doesn't matter to me which one you sign up for. If you're in Tepper, you're required to sign up for the Tepper number. The other 2 numbers are pretty much identical. It's Monday and Wednesdays, 1:30 to 3-ish. Our room is downstairs, 1305. And obviously, it's at the same time in California. So we're using this system called Panopto, which I think is a CMU spin-off company, to record and simulcast it. So if anybody misses this lecture or misses any other lecture, you can catch up by watching it at home. And all of the, was that, you got it? Okay. If you go to the course website, which is here, and there's a link to this website from the course main page, or from my home page, you can get to it. There's a link to it from Blackboard, so hopefully everybody's found this page. And on the schedule page, right here under class materials, will be a link to the video. So and eventually all of these will be filled in with all the videos from the course. And, okay. So we have, there's a whole bunch of people on the wait list who think they want to be in this course. Obviously, I'm not going to let 130 people try and fit into 1305. So again, it would be polite for your classmates if you decide after this lecture you don't want to actually take the course if you drop it expeditiously. I hope you all stay in the course. This is me. And I don't have any particular office hours, but I'm usually working from work. So if you have questions, you can ask me. There's seats over here. And if you have problems with your registration, depending on which number you use, there are different people to contact. And if you still can't figure out things, then you can talk to me. So I have 4 TAs. There's some seats dead in the middle, which will be tricky to get to. I have 4 TAs, so that's enough to actually handle 100 people. So if you guys actually want to stick it out in the course, that's fine. Might be a little crowded in our lecture room, but we can actually grade all your homeworks without any trouble. These are all HCI majors. I mean, they're people who have HCI backgrounds, and so they'll be very helpful in understanding the material. They will hold office hours, but we haven't figured out the schedule yet, but the office hours will also be listed on the staff page. I see one seat, then 2 seats, then whoever's here has to stand. Hopefully you've all found the web page in advance. The schedule is going to be put there. The homeworks are going to be put there. We're just using Blackboard as a way to turn in your homeworks and for you to get your homeworks back with comments on them. Okay, so don't be surprised if there's very little content on Blackboard. It's all on the course's web page. And for those of you who are not in Tepper, it turns out that Tepper has its own schedule, which is a week after main campus's schedule. And since we have about a third of the class as Tepper students, we were pretty much required to follow the Tepper schedule. So one of the consequences of that is that the course extends past the normal end date for regular classes. All right, so in what is main campus's exam week, we have 2 lectures, and then we have an exam. This is all in the exam week. So you need to, in terms of your planning, if you're planning to, say, go home at Christmas, you will need to make sure that you don't leave before the final exam is offered. So the first time it's going to be offered twice, once for main campus people and once for Tepper people, but both rooms are big enough for everybody. So if everybody wanted to come on Thursday, that would be perfectly fine with me. We just get our grading done fine. But if you want more time to study and you feel like sticking around, you can all come on Monday as well. So, but in terms of your plane flights home, do not leave before Thursday, December 17th, or in particular Friday, Thursday night or Friday, or else you won't be able to get the final, do the final work. And we do have 2 lectures that final week, which are important, also fun. And so this is during main campus's exam week, but that is important. You guys could come over and stand over there if you want. Whoops. The readings for the course are almost exclusively from our textbook, but there are some other readings that are optional, and you can see all the readings in the whoops. All the readings are listed on each page here. So there's a required reading, which is usually in the textbook, and then there's a bunch of optional readings if anybody's interested in getting more information about the topics that we're covering. I strongly recommend everyone either get or borrow the textbook. It's also available as an ebook version. So we developed, my friend Rex Hartson was developing this textbook, and he sent me a very early copy about 4 or 5 years ago, and we used it in class, and he improved it based on our feedback. We did that twice, and then finally it came out. And so this is the 4th year we've used the actual version, and it's really very useful. Now, it's a little daunting being 900 pages long, which is completely insane. So I've only really assigned a very small number of chapters from the book, but you really won't be able to do the homework unless you read the chapters that are assigned. But it's a very small section of the whole book, so you don't have to think that you have to read 900 pages to go through the course. Rex has said that he's planning a revised version that's smaller and more focused in the soon. I don't know what he means by soon, but if you have feedback on the textbook, I'm sure he'd be delighted to have it, and you can send it back to me. There's a variety of other books if you're interested in the user interface features. Byron Holtzblatt is a very detailed book about the stuff we're going to do in the first assignment. Jakob Nielsen's book on usability engineering is old, but it's very interesting. And Don Norman's book, The Design of Everyday Things, is a very slim, very fun book that I highly recommend if you are interested in that kind of thing. All of these are optional, really just for people who think that this is interesting. By the way, the slides are already on the schedule website. So, if you want to go back and read some of this or use it, then that's perfectly reasonable. Another point about the slides, by the way, is that every year I make a new website. So if you go back to last year's, you'll see it's kind of similar to this year's, except it's red instead of green. And I put this banner on the top of every page just so you don't get confused. But the advantage of this is if after you take this course and you go off to industry or wherever you're going, and you say, there's this thing I learned in HCI class I'd really like to go back and look at, that page will be there forever with all the videos and the homeworks and all the materials. So hopefully, you might find this useful. Another thing that you might use last year's for is if you want to read ahead or look at the videos from last year or even look at the homeworks from last year. Ours will be slightly different, but pretty much the same kind of thing. It's very much the same course as last year. So that might be useful if you need to reference what's gone on. Okay. So what is this class about? This is, the topic is human-computer interaction, also called user interfaces, user experience. There's a lot of names for it. There's some old names that nobody uses anymore, like human factors or ergonomics. Man-machine interfaces, which is really very sexist, and those kind of terms aren't used anymore. But they used to be, so you might see some of these in some of the classic articles or whatever. Basically, it's a way of making all of your products, anything that has people to use it, ways of making them better. And the HCI Institute just celebrated its 20th anniversary. We've been teaching this material for about 18 years. We formed a master's program in HCI almost immediately. And we went through a lot of different user interface methods, user interface techniques. And it basically came down to these four as the most important. And so the goal of this course is to give you an understanding of the key user interface techniques that have been proven to be both accessible, that people can use without too much trouble, and also that are very effective. Okay? And so what you're going to do in this course, of course, the 6 homeworks, is actually learn and actually do these 4 methods: contextual inquiry, rapid prototyping, user studies, and heuristic analysis. And because these are ways of studying people, they won't become obsolete. So you can use a contextual inquiry on an old-fashioned desktop computer. You can use it on a laptop. You can use it on a phone or a watch. You can use it on a smart television. It doesn't matter what the product is that you're studying. You're studying how people react to it, and that doesn't change. And you can use it to study kids or experts or novices. So these techniques are very much agnostic, if you will, based on what it is you're evaluating and what it is you have to design. And similarly, with rapid prototyping, you're going to design, as part of this course, you're going to try and design an improved, a better user interface for something, right? And that is also something that will never go obsolete, right? You'll always be designing something, whether it's a watch or a phone or something we haven't thought of yet. You still needs to be designed, and that's still a technique that will always be useful. So this course is about actually teaching these systems. And sometimes I've gotten the question, I don't want to actually learn to do them, I just want to learn about them. Well, that really doesn't work, because you really won't understand them unless you actually go ahead and do them. And so unfortunately, to actually do them in a 7-week course requires that we have a fair amount of homework, and that the homeworks are somewhat long. There's no requirement that you be able to program. The first couple times I tried to make people program, and that was a dismal failure. So we don't do that anymore. Everybody will be making prototypes, but you can make them with any tool you want. So if you're the default tool is PowerPoint, so you'll be actually making a pretend version of your iPhone or whatever in PowerPoint. And if you've ever looked at PowerPoint, you can have hyperlinks, you can have buttons. So PowerPoint turns out to be a surprisingly powerful prototyping tool. But you're also allowed to use tools like Balsamiq or Axure. There's a whole bunch of great tools out there that anybody can learn if you're interested in learning something new. So there's absolutely no need to script or write JavaScript or HTML or Java or anything like that. And so there shouldn't be any reason why anybody can't succeed at this course. The schedule for the homeworks is already up, although the homework content is not. They're due before class, and the goal of that was try and make it so there's no good excuse not to attend class on that particular day. And if it's late, we have a fairly liberal late policy for the first 3 assignments. So it's 10 points off or 1 letter grade, 10 points out of 100 for each class period late. So it's due on Wednesday. You have all the way till the next Monday to turn it in before you get, and then it's only 10 points off. And then if you miss Monday, then it's another 20 points off and so forth. However, the last 2 assignments, we're going to be swapping amongst the class. So your assignment 4 is going to be given to your colleagues, to your classmates, and they're going to give something to you. And so there's no way to do that if you're late. So for the last 2 assignments, you have to turn them in on time. But as you're getting started in the course and figuring out how much work it is, and typically people find the first assignment to be the most difficult, you do have a little leeway in turning them in late. But the consequence is there's no freebies, right? The assignment is due on a Wednesday at 1:30, and if you're late, you get 10 points off. So unless there's something really dramatic going on. And so anyway, if you have to go out of town, you're always welcome to turn in assignments early, but there won't be, I have an interview or whatever, I don't care. If you want to take the 10 points off, that's fine. Otherwise, get it on time. And you can do it remotely. Obviously, people in Silicon Valley, it's all done electronically. Everything will be uploaded to Blackboard. We talked about the final exam. It's okay to take this course pass-fail. A number of people have asked that already. And if it's up to your program, I don't care. And what does pass mean? The course is graded by number. So there's a very simple formula on the web page. So if you go to the syllabus, there's a lot of great information here, prerequisites, talks about the textbook, talks about the amount of work. So this is a fairly involved amount of work. So it is a 6-unit course, which means 12 hours of work a week. So you're in lectures for 3 hours a week. So that leaves 9 hours for homework. Typically, people report that's about how much they spend. But it seems like many people are not expecting that amount of work. So I actually looked it up in order to find out, to make sure I was right that I'm allowed to give you 9 hours of homework a week. And that's certainly consistent with what it's supposed to be. And unfortunately, as I was saying, you can't really learn to do these techniques unless you go out and do them, and they take a little bit of time. We've worked very hard to try and make sure they're not repetitive and boring, and we've taken out some of the requirements that people found particularly onerous. And I'd be perfectly interested in your feedback. Like I said, I've offered this 10 times, and we change it every year. So if you have some thoughts on how to make it more interesting, that would be fine. Unfortunately, we can't let anybody audit. As you see, the room is full. You're welcome to watch the videotapes if you want to not take it for any kind of credit, but we really don't have room for you to be in the room. Oops. Right, so amount of work. Homeworks will be submitted online. Oh, here's the grading criteria. Homework 0 that we're going to do, we'll talk about in a minute, is a freebie. And then all the homeworks are 12 except the last one, which is really easy. And then we do have a final exam, which is a closed book, 3-hour exam, as I mentioned, given twice. And so basically we'll figure out your percentage based on the number from all of your homeworks, and that's the grade you're going to get. And in terms of pass-fail, it's kind of up to your program what counts as a pass-fail. So I'll ask your advisor, does a C count? And if a C counts, you can get to a 70. If you have to get a B plus to pass, then you have to get 85 or something like that, right? So it's up to your program what counts as a pass or a fail. Late policy, I mentioned. No cheating. Okay, we're required to have this really enormous section here to make it clear that we don't like cheating. Okay. Said that already. Oh, and we recommend you take advantage of the office hours. The TAs are really good, and they'll be able to help you if you're confused about things. Okay, so what is the homework like? So in this course, everybody is going to do all the homeworks individually. Okay, and what you're going to do is pick something, a web page, a device, an app on your phone, an app for a laptop, any kind of appliance, Red Box down at Giant Eagle, or a kiosk at the airport. Oh, that's probably not a good idea. And you're going to study people trying to use it. That will be assignment 1. Assignment 2, you're going to try and invent a better way, a better user interface for it by just drawing that interface on paper. I'm going to get this confused. So let me go to the website and click on the homework tabs. Right, so homework 2 is you're going to make a paper prototype. And homework 3, you're going to take your paper prototype and actually test it out with people. Typically somebody who's not very tech savvy, and see if they can use, if it seems like that what you've done is actually better. Then you're going to implement it, and this is the one where I said you'd probably do it in PowerPoint or Balsamiq or some other prototyping environment. And then for homework 5, you're going to critique each other's designs. Okay? And then for homework 6, you're going to fix it up based on the critiques. Everybody's going to do the same device, the same user interface throughout the whole course. And so it's important that you pick your device wisely. And also, in order to avoid any kind of cheating, everybody picks something different. Okay, so what we're going to do at the beginning of the next lecture is try to make sure everybody has something different. And I'm going to go through everybody's proposals and try to make sure that they are complicated enough. Okay, so if you remember, you're going to do a user study. The first thing you're going to do is a user study. And if everybody can do it really easily, then you really won't get anything useful out of it. So you need to pick something kind of medium level of complexity. And here's a bunch of examples. And it's not sufficient to say I'm going to do an iPhone, right? Because an iPhone has, thousands of things you can do with it. But you could certainly say I'm going to do the contact list feature of the iPhone, or I'm going to do SMS interface, although that's probably too easy. And there's a whole bunch of ideas here of things that you can do. It goes on and on. So there's 65, but some of these are basically like just a website. And obviously there are millions of websites out there. Sometimes I've been asked, if you already have a little company that you're starting, can you use your own website? And that's fine, as long as you don't mind people seeing it. You can't make your classmates sign an NDA to see your website, but if you'd like some help with designing it, that would be a great thing to use in class, or a class project, or anything like that. It's fine to use devices like a camera. Anything electronic is pretty much okay. The problem with using like kiosks at the airport is that you have to get people to go all the way through, and it's a little awkward to try and make people go through in something like the airport where they can't really do it. If you want to use something in your home, that's fine, as long as you don't mind people coming into your home to use it. It's also fine to use appliances you find around, like the copiers and mechanisms like that, which are surprisingly complicated, or like these projectors. What else? Oh, how are we going to assign them? So I've already put, if you go to Blackboard, which I forgot to log in, so it'll probably complain. You'll see I already put the link up. Maybe some people have already tried it out. Yep, lots of people. This is the place where you're going to fill in what you want. And what I'm going to do before class on Wednesday is go through and mark the ones that seem okay to me and add comments. And then the ones that don't seem okay, we'll add some new, we'll go through in class and try and make sure everything is consistent. So what are you supposed to do? You're supposed to pick something that no one above you has picked. So in order to be fair, I took everybody who was registered for the course as of last night and gave everybody a random number and then sorted by the random numbers. So it didn't seem fair to sort by your last names because that's not fair. So some people are lucky and some people are less lucky. And if you're not on this list, I see, then just add your name at the end because obviously you weren't on the official registered yet. So a few things I've already noticed, like Kindle, that's too vague. You have to pick some particular task to do with the Kindle. Or oven range, you should put down the model number. So, it's okay if two people do an oven as long as they're totally different ovens, right? So that's why I'd like to know which oven you have in mind. So if it's a Samsung oven and somebody else is doing a different kind, then maybe that's okay. So here's some great, very specific things. It seems reasonable. The trick with something like the Giant Eagle checkout thing is you're going to have to do a user study of somebody actually doing it, which the market may or may not be happy about, right? So that might be a little bit of a problem. It's okay with me if you try it, but it might turn out to be a problem. Programmable microwave, again, which model, things like that. I don't know what this is, so probably more details. If you're using something interesting like a website I've never heard of, then put it in the full URL so I can figure out. Okay. Any questions about what you're supposed to do for this? Okay. Some people will put something down and have it approved, and then they'll try and do the first assignment and discover it really was too easy or too hard or impossible to do or whatever. In that case, you are allowed to change, but you'll have to change to something that nobody else had already picked. The other point is that some people will probably pick something and then drop, and then their devices are up for grabs. So if anybody who picks a device drops, I'll move them to the bottom of the list. And so you can see that there'll be a list of things down here that you could pick from. Okay. You don't have to do this during class. You could do it later. And it doesn't really matter. Given that everybody's in sorted order, if you see something below you that you really like, then you could be mean and pick it. So if you're lower down, it might make sense to just wait and make sure no one picks what you are thinking of anyway. So whatever strategy you want to use is fine. But everybody's devices need to be listed there by Tuesday night. Okay, so that was the logistics. Any questions about the logistics for class or homework 0? Okay. So now I'm going to try and convince you why this is the most important course you could be taking in the second mini or ever. Talking about user interfaces as a field and user interfaces as part of a product. So one of the key things to consider when you're talking about user interfaces is obviously what does that term mean? What is the user and user interfaces? And it's pretty straightforward. It's the people who will use your product. And this is as opposed to the designers, which are the people who are making the product. And the key observation is that the designers are not the same as users. So a question I like to ask is, how many people in this room are above average? Okay, so all of you are liars because you wouldn't be at CMU if you were average, right? CMU doesn't take average people. Everybody in this room is 1 or 2 or maybe 4 standard deviations above average. How many people, when they're making a product, are thinking, you know, I don't want any average people to buy my product, right? My product is only for smart people, right? That doesn't make any sense, right? So you as an above average manager or engineer or whatever your focus is, you are not the same as the people that you hope are going to use your product. Because if you only aim it at people who are as smart as you or who have the same interests as you, then you're going to be cutting off almost all of the market. And so the key, a lot of the mechanisms and techniques that we're talking about in this course are trying to help you know the user better, right? Who are the users? How are they thinking about things? How are they different than you, the designer? And what is the user interface? It's basically everything the user encounters. Okay, so you may be thinking of the user interface as the icons and the colors, but it's a lot more than that. It's pretty much everything on this list and basically everything that's in the product. So a lot of the techniques, especially the first one that we talk about, really are getting at usefulness, which is very different than usability, right? Is this product doing something that people want? Is it doing something that will help people or that people will find makes their life more efficient? So that's the functionality and usefulness. How do you go about knowing what you want in a product? And there's needs analysis. There's a lot of different ways of dealing with that as a question. And we'll be teaching you a method that gets at that. There's the content, which is particularly relevant for web pages, but also for other kinds of products that have labels or names or any kind of words on them. What should those words be? What should they say? How should they express it? What is going to be clear and understandable for your users? How should that be presented? What colors should you use? How should you lay things out? It turns out that people go read their interfaces from top left to bottom right in the same way you read a book. And so how would you organize the material so that it comes out in a logical order and people know what to do first and what to do second? Navigation is very important on web pages, but also on lots of consumer electronics. So if you have a fancy camera and you're trying to set the, light balance, that's probably 2 or 3 steps down in the menu system. How are you going to get it so people know where the white balance is and so they can find it again? Or kind of any kind of system that doesn't have an enormous screen is going to have lots of little choices. Think about the watch and how many taps it takes to get into anything at all on an Apple Watch. What is the navigation scheme? How are you going to make that clear? It even relates to things like the speed of response. So you might think that's entirely an engineering choice, but it has a big impact on people's interactions, right? People will often say, if I click this button, that's going to be slow. So instead of doing that, I'm going to do this other thing. Or this website is so slow, I'm going to ignore it and go off to a competitor's website. And so the user interface is visible, their speed of response is visible in the user interface. And then there are things like emotional impact. How many people love their phone? Okay, so people have this emotional connection to some products. How many people love Microsoft Word? Right? And other things people don't have so much emotional connection to. I'm sure I could come up with something for the people who love Word that they're not so much in love with. And so how can you design products that have this kind of connection to people, that really help people feel good about purchasing it or using it or showing it off to their friends? And then, kind of obviously, documentation and help is important as well. So the book differentiates user experience, which includes all these, especially the emotional impact and stuff, from user interface. I'm not making that distinction. I think both words are perfectly reasonable for both of the, for covering all of these aspects. So think about some system and think about how you would classify it as high quality as opposed to low quality, right? So a high quality, automobile, everyone knows what that means. It doesn't break down. It looks nice. There might be various aspects for quality of a car. Suppose we're talking about a technological user interface. What are some, or a software product, what would be some of the attributes or metrics that would be, that you call it high quality?
Stability.
Stability, like it doesn't crash?
Doesn't crash.
Okay, that's good. What else? Responsiveness, so it's fast when you click on things. What else? Yeah? Cohesive, what do you mean?
Like your experience is like sort of consistent throughout the
Yeah,
application.
right. So consistent, that it seems like the parts fit together, that consistency means that you do something in one part of the interface, works the same way in another part. What else? Yeah? Intuitive, so that you can understand how to do it. Yeah?
Similar, I was going to say ease of use, where there's no need to do a help section.
Okay, so that, right, so you can figure out how to use it without using help. What else? Yeah? Yeah, so aesthetically appealing, visually appealing, and also, other parts of the interface that might have sounds, and that should be appealing as well. So predictive, it gets easier to use with time. Good. What else?
Does what it is expected to do.
Sure. So the user has certain desires and expectations in mind, and if the interface does as expected, then it'll seem a lot easier to use. Okay. Oh, easy to understand? Yeah, sure. That's a good point. So it's not just what you have to type, but it's what the interface sends back to you, right? And so easy to understand so that you know what the system is trying to tell you back. So that's another good answer. Okay, so I have some things here. One thing nobody mentioned was learnability. I guess that's kind of an intuitiveness maybe. But the idea that a novice can walk up to this interface and start using it right away. Efficiency, we didn't actually talk about, but that's another key user interface focus, is if you're an expert at the system and you use it a lot, you should be able to use it quickly, right? And so some people think of user interfaces as just for novices, but in fact, we actually spend a lot more attention on expert use, on how to make sure that experts are not wasting a lot of time, don't have a million clicks that seem kind of stupid, right? So productivity and efficiency. Memorability is the idea that if you do something and you go away for a month and come back, you remember how to do it. And then things like errors, we didn't really talk about either. It's avoiding errors is an important usability feature. And so these are all, and satisfaction. These are all aspects of user interfaces, of usability, and that's what we're going to learn in this course about how to improve basically all of these at the same time. So we talked a little bit about user experience in terms of emotion and things like fun and style and art. And by the way, another thing I forgot to mention with respect to the devices is it's usually not a good idea to pick a game, okay? Because games are hard to use on purpose, right? You could have an interface that says win in a big box, and that'd be really easy to use, but not a bit fun, right? So the way that games make themselves interesting is by actually being hard to use or hard to have a lot of barriers along the way that you have to figure out ways of overcoming. And so unless the game has a really interesting mechanic that you want to actually test the mechanic or the setup of the game, which is usually kind of boring. But in general, games are not a good choice because even though they're lots of fun and they may be artistic, in terms of the kind of things that we're teaching in this course, it's really not very effective. There are courses from the Entertainment Technology Center and so forth that focus on measuring fun and engineering games to be fun, but that's kind of not a main topic of this course. But even something like an iPhone app can be fun. A lot of the animations and the wiggling and swiping and stuff are fun to do, and so that's can be a reasonable goal for regular products, regular interactions as well. User experience also includes branding and political and a lot of things beyond the device itself. So service design is understanding the entire, all the different parts, not just the interface itself, but how it fits in with your life, basically, and how it fits in with other things that you're going to do. So why is it that it's important to focus on user interface for your products? Well, one reason is that everyone pretty much expects all products today to be easy to use, right? No one expects to read a 100-page manual before they start using something. It's usually pretty tricky even to get a manual for something if you wanted to, like, try to find the manual for your cable box. They don't even give them out anymore. Usability is a key thing that people evaluate when they're trying to decide what to buy or when they're reviewing products on blogs and stuff. And it turns out that there are well-defined methods for improving the usability, and that's what we're going to be focusing on in this course. So even if you are thinking, I'm not a designer, there are still lots of methods that anybody can use, engineers or managers or whatever, in order to measure interfaces, to improve user interfaces, and to test out different approaches. Naturally, in a 6-7 week course, I can't bring you to the level of an HCI expert or somebody who's done a year in our master's program and learned lots of different techniques and lots of experience. But hopefully, one of the goals of this course is to give you an appreciation of what those kinds of people can do. All right? Appreciation for how hard it is to design good user interfaces and what sort of techniques and approaches a user interface specialist will bring to your team, assuming you're a manager or product lead or whatever. And so there's plenty of evidence that people with HCI training can do better interfaces, but even the level of training that you're going to get from this course will improve your ability to make better interfaces. And it will certainly give you a good understanding if you then are in teams with HCI specialists of what they're going to do and what they bring to the team. So there's plenty of bad interfaces in the world. This is kind of an old example. It used to be that appliances had a clock that you had to set. How many people have clocks that are still on daylight time? And how many of those are because you couldn't figure out how to fix them? So that's still an issue. This is our old friend Randy Pausch, who used to start every course that he taught on user interfaces by taking a sledgehammer and smashing a piece of consumer electronics as a way of channeling people's frustration at the poor quality of the user interfaces on these devices. How many people have more than one remote? Right? And they're all slightly different. And this picture was taken a while ago. There were remotes with displays, which you really don't see anymore. Button layouts are always different, and they're always poorly made. This was a really fun article way back in 1991, which is a surprisingly long time ago, that says, I can't work this bleep thing. And then if you read it, from VCRs and telephones to copiers and microwaves, poorly designed machines cluttered with unwanted features are driving consumers crazy. Whatever happened to user-friendly? If we take this article today and replace VCRs with DVRs, right, and replace telephones with smartphones, right, this is still the situation pretty much. That there's been surprisingly little progress in many kinds of consumer electronics, whereas other things, on the other hand, have finally gotten to be a lot better. why is it important for companies to think about improving their user interfaces? Well, there are lots of benefits to customers. Novices will be more efficient, more effective quickly, so that people won't be wasting so much time trying to learn your system. Experts are more efficient, so we talked about efficiency. Most white-collar workers spend most of their days working at computers, and so to the extent that you can make them more efficient, that will have a big impact on the amount of work people can actually get done. It reduces errors, and so a lot of the user interface techniques that we're talking about actually can help you make products where people don't make errors as much, or detect errors more quickly, and repair errors more quickly, and so that's obviously a key advantage. And then finally, as we talked about, this emotional connection, that people are proud of using your product, which certainly generates a lot more productivity and a lot more satisfaction. There's been some studies to look at, what is the cost of usability, and almost all of these studies always show these incredible gains, incredible return on investment of spending a little money on usability. And that's because the kinds of things that usability fixes usually are really expensive. And so, for example, if you have a system that people are getting confused about when they try and set it up, then they'll probably call your help center. And every call to the help center costs like $50 or some ridiculously large number like that. So if you have a product with a fairly small profit margin, then pretty much every call to the help center means another dozen products that you didn't make any money on, right? And so to the extent that you can make it so nobody has to call the help center because everybody can figure out how to do something, well, you've saved a lot of money that way, pretty straightforwardly. Reduce complaints from customers. Another important point is that it turns out the first assignment, the contextual inquiry that we're going to do, as I mentioned, is about needs finding, about understanding the real requirements for your product. And that can help significantly reduce your engineering budget because you'll have a much more clear understanding of what this product has to do, right? And if you can actually spend money on features that users want, well, then you don't have to waste a lot of money making features that no one wants to use. And so by understanding what's really needed, you can make a product that's much more effective and much more focused on what's going to help. It turns out that engineering, and particularly software development, is really expensive and really hard to do. And an enormous amount of engineering effort across the industry is wasted on things that actually never see the light of day, or which are released and then have to be retracted or fixed later. And so a lot of studies have shown that one of the key reasons is a lack of attention to user needs and the lack of doing the kinds of things that we're going to be talking about. So in assignment 2, you're going to make a paper prototype, which will probably take you 3 or 4 hours. And it will let you really understand, how people would want to use this product, how people react to it, will people find it useful. And by doing these really cheap and inexpensive mechanisms and processes that we're talking about, you can really have an enormous impact on the bottom line of your company by showing which parts of the product are needed. Another cool thing about having a better user interface is that it makes it much easier for your salesman to go off and show people what this does because it'll be obvious what it does. And the salesman will understand it better, the customers will understand it, and so the product will be easier to demonstrate and sell. To the extent that you put your engineering dollars where the users actually want to use, that will increase what's called the realized value, or the money you spent actually is working for you. And to the extent that you can differentiate your product from the competitors through usability, that will obviously increase your revenue and profit. So there's a lot of business and money reasons why usability almost always pays off. A number of people who've taken my course have told me that they've actually used the product that they designed as part of their portfolio on graduation. And we've certainly seen that there's an enormous demand for people who have user interface experience or user interface knowledge. There's plenty of jobs for user interface specialists, and even saying that you want to be a manager, but you have some user interface experience or an engineer or whatever, can be a real benefit for your resume and your job search. There's also plenty of money and time devoted to user interfaces across all companies and government and military establishments as well. And the key quote is that if the user can't use it, it doesn't work, right? And so you might think a feature or a system works if the QA department can't find any bugs in it. But even if the department can't find any bugs in it and you give it to users and they can't make it work, well then it might as well not be there. It might as well not count, because if you've not tested your product for usability, then you really haven't tested it at all. And a corollary, especially for web products or anything with a deep menu structure, is that if the user can't find the feature, it might as well not exist. And there's this great study from Best Buy that something like 2/3 of the products that were returned to Best Buy were returned because people claimed it didn't have a feature that it actually had. And it was just that people wanted this and wanted it to do something for them and couldn't figure out how to make it do it. So they assumed it wasn't possible, and so they returned it. And obviously that's an awful lot of money that Best Buy didn't make, and also all of the consumer electronic companies as well. And in the converse, on the other side, you have usability really defining and making products successful. And the classic example is the Palm Pilot. How many people have heard of the Palm Pilot? It's a big product in the late 90s. How many people know what this is? And you notice the Apple logo. Right. So this is the Apple Newton. I don't know if anybody saw the Steve Jobs movie. They made fun of this. This was a failure product, a product that was a failure of Apple at one point. It was too big and heavy. It didn't really do what people wanted it to do. Whereas on the other hand, when the Palm Pilot came out, it was very successful. One reason is it fit into a pocket. Another reason is that they very carefully designed the interface so that what people wanted to do was really easy to do. And so they spent a lot of effort on understanding people's needs, on doing user testing, and figuring out how to make the Palm Pilot actually be responsive to what people wanted. Who knows what this is? It's the original iPod. Anybody old enough to have had one? Yeah, a whole bunch of people. So the iPod was not the first digital music player. In fact, there had been digital music players by many competitors for years. Microsoft even had one before this. Nobody wanted them. And one of the key reasons was that they all had little buttons for like next track, previous track, like you have on your car or whatever, on your CD player. But when you had 100 songs, next track and previous track were just totally losers as ways of user interface, of picking things. So the original iPod had this very novel circle thing, which they very carefully engineered so that if you went fast, you could get through all of your 1,000 songs really quickly. And if you went slowly, it was accurate enough that you could pick an individual song. And if you've ever played with one of these, you can actually explore how, in fact, it goes at very different speeds. The little marker, the cursor, goes at very different speeds if you go fast or slow. And they've spent a lot of effort engineering that so it was very easy to use. But another important point was at the time, it was, if you had one of these other players like a Zune from Microsoft or whatever, a Rio, it was really hard to buy a song, right? And this was a time when all the companies were up in arms about people stealing songs and about ripping off CDs. And Apple not only created this device, but they created the iTunes Store, which made it cheap and easy to to buy songs in a legal way and a really good user experience. So we talked before about service design. So one of the key reasons the iPod was so successful is Apple did service design. They designed not just the iPod, but they also iTunes, and also Apple, Steve Jobs was able to make deals with all the major record companies so that all the songs you wanted were available legally and in an easy to find way, because many people didn't want to break the law to own a song for 99 cents, right? That just seemed too silly. So by considering this entire process, they were able to make the iPod a big success. And the original iPods were fairly large and clunky because they had an actual hard disk in them, the spinning hard disk. So if you ever opened up one, it's kind of interesting what they had to do back in that period in order to make it work. Everyone knows what this is. This is the original iPhone. Looks kind of small today, but it turned out that it was very revolutionary at the time as well. So you remember the the Palm Pilot had a full screen, was just a screen. How many people remember the BlackBerry, BlackBerry? So it had a little keyboard that you clicked on with your thumbs. And it turned out that everybody was going in that direction, that Microsoft and Palm had all given up on the full screen and had gone to half screens with a little thumb keyboard, because that seemed to be what everybody wanted. And Apple said, we don't care. Yeah? I did not. The volume? No, this was a song selector. You could also do volume with it, yeah. Right? I mean, but the cool thing was, and there was this big button in the middle and 4 buttons around the outside.
He was asking, why was it hard to engineer?
Okay, thanks. Right, so the trick is, if you go slowly, you have to be able to click each individual song out of a really long list. But if you go fast, you want to be able to get to the song you want, right? And it might be 1,000 songs away or 1,000 records away, right? Because you could fit like I forget the original iPod, but I think it was like 1,000 records, 1,000 albums. And so how fast should that go? And where should it change? Suppose you go at a medium speed, right? It's really easy if you design these things wrong to make it so you always are overshooting, right? Okay, I'm on Yellow Submarine and I want to get to an A song, right? Or a B song, right? If you want to go to A, you just go all the way to the top. But if you want to get to B or C, you spin it and you shoot past it and get to somewhere you don't want. So it turns out that there's what's called a transfer function. Wasn't it like the volume knob? Is that the same question? Yeah. Okay, yeah. But no, it's not like a volume knob, because the volume knob has a very linear or simple mapping between the volume and where the knob is, right? So it's a linear, but the relationship between the speed, so if you map the speed of the finger to the speed of scrolling, you might think it would be a nice linear curve, but that actually turns out not to work at all. And so there's a transfer function which actually has different sections with different speeds. And this isn't anything like the real transfer function, but it is a fairly complicated shape that lets you actually control the song selection in a way that's most effective. Right. So the iPhone was where I was talking about. When the iPhone came out, it was pretty much the first phone to use multi-touch. And if you know anything about the screens of these old devices, they were designed to use with a stylus, a pointy thing. But you can't use a pointy thing on an iPhone screen, right? And so you had to use something like your finger. And Steve Jobs was very much against styluses and in favor of fingers as an interface. And so obviously they threw away the Newton handwriting recognizer and all that kind of stuff they'd done before to make it so everything was a nice big button that you could hit with your finger. So it was very revolutionary at the time because everybody else was going a different way. And obviously, it completely took over, and all interfaces work this way now. Similarly, with the iPad, nobody thought that was going to be useful because Microsoft and many others had tried to have pads for many years, had tried to come out with tablet machines. So Microsoft had something called the tablet PC that Bill Gates got up and said is going to be the next big thing, and turned out nobody wanted it. So it turns out that virtually nobody wants to do handwriting anymore. So I see maybe 15 people with actual paper. But most of your generation really isn't much interested in handwriting. And so the concept of a tablet as something you handwrite on was a non-starter. But Apple's big innovation or observation was that this should be a media machine, right? So most people use their iPads for movies and games, for reading, right? But not so much for writing or for providing input to. And then the next example is the Wii. So back when the Wii was first announced, Microsoft and PlayStation and Nintendo were all competing on making faster and bigger and more sophisticated consoles. And the Nintendo Wii was actually slower, dramatically slower than all of its competitors. And instead, they put their money into these innovative controllers, which had motion sensors in them. And everybody else was just using the conventional twitch fingers kinds of controllers. And the Wii, for a time, totally dominated the market simply because they'd come up with this new user interface and a new way of playing games, a new kind of games that you could author. And they proved that you didn't really need all this extra graphics and power that everybody else thought was the key requirement. So these are all examples of where good user interfaces have really defined and enabled these products to be successful. And this is also true for the web. Websites are really much defined by usability, or usability rules the web. Obviously, if pretty much whenever anybody goes to buy any kind of product, they first look it up on the web. So even if you're going to buy a physical product like a car or a copier or printer, you're going to go look it up on the web first. But if you're going to use a web service or an e-commerce site, then you're going to actually buy things on the web. So if the consumer can't figure out how to use your website, can't find the products, then basically they're going to go somewhere else. And the interesting observation is if you physically go to Giant Eagle and it doesn't have some product that you want, it's a lot of trouble to get back in your car and then drive off to CVS or whatever in order to see if they happen to have this product, right? Whereas if you're on Expedia and you're not liking the user interface, it's really trivial to switch to Yahoo Travel or some other website, right? So your competitors are only one click away compared to a physical store where it's a lot more trouble to switch. Another interesting thing is that Google does a pretty good job of searching, and Amazon does a pretty good job of letting you buy the products that you want. If you have this cute little company and you have a search field or a buy something field, people aren't going to really compare your site to other little sites. They're going to compare it to Google and to Amazon. If you go into a GetGo and you're looking around on the shelves and they don't have some product that you want, you're not surprised because it's really obvious it's a little store, right, compared to the big Giant Eagles. But that doesn't hold for websites. That if your little website doesn't have a decent search or doesn't have one-click purchasing or doesn't operate in a good way, unfortunately, people are going to say, well, Amazon can do it, not necessarily taking into account the fact that Amazon can spend $1 million on each page and your little website can't. Another thing that's related is that there's been some studies of companies that have poorly designed websites, and it reflects really badly on the brand name, right? So if you're BMW or some other luxury brand and you're thinking, oh, well, everybody's going to love my cars. I don't have to worry about my website. This study shows that that's not true, that if BMW has a really awful website, people are going to think, well, this company obviously doesn't care about usability. Their cars are probably hard to use too, so maybe I'll go somewhere else and try a Mercedes or whatever. And so even though it may not have anything important to do with your what you're actually selling, that the website usability is a key requirement. Another interesting thing about e-commerce sites compared to regular software is if you're trying to buy a product and you want to use it, you have to pay for it first. So if you have a laptop or a piece of software, sometimes you can get it on spec. But any kind of hardware or consumer electronics, you have to pay for it before you can use it. Whereas with anything on the web, the very last button is where you actually get the money, right? And so if anything is confusing about the purchasing mechanism, or if people get annoyed at you halfway through the shopping experience, they'll just leave and you won't get any money at all, right? And so that's a big difference of the web products, is that the money comes only after people have already done the using. And there are a number of examples where bad user interfaces have done some really awful things, and the simplest or least awful is actually reducing the value and the ratings of companies. So this is a great example. Ford had been working for many years on improving the quality of their cars. They used to, a long time ago, have a reputation of cars that fell apart. So they worked really hard on the engineering, made the cars so they didn't break down as much, so the motors were more reliable and all the other pieces were reliable. And then in 2011, they decided to go to an electronic dashboard like everybody else, but they did such a lousy job of it that their quality ratings dropped dramatically, just as a result of the not realizing they need to spend so much money on the quality of their dashboards. And some of the reviews were pretty damning. The annoying behavior of their driving faces interactive system that caused their ratings to plummet, right? So this is something that people have to deal with. So it perfectly makes sense that a poor job would make it so that it's hard. Here's another example that's a little more recent, but still with Ford, that drivers were accidentally hitting this button when they meant to hit one of these other buttons. So this is park, rear, drive. So this is how you switch gears. And this is how you turn the car off, right? And so sure enough, drivers were accidentally turning off the car while they were driving down the highway, trying to switch to S, for example. And also passengers, when they were trying to turn the radio off, were turning the entire car off, right? And you can imagine that that's really dangerous if you're driving down the highway and suddenly your car is turned off. This article says that 13,500 cars had to be recalled. Now, how do you even fix this in a recall, right? I mean, they maybe have to replace this entire device or something. There has to be a way to turn a car off, so I have to move somewhere else. Here's another great example. I couldn't find the more up-to-date numbers, so this just goes to 2013. But if anybody knows of the up-to-date graph, this green line is Nokia or Symbian, kind of hitting 0, and the blue line is Android, right? The interesting thing about this is the purple line is iOS, is Apple, and it really hasn't dominated in terms of numbers the way that you might imagine, but it is still the most profitable, Apple's still the most profitable, highest valued company in the world. One of the reasons is because of their user interfaces and other design elements, they've been able to hold the line on cost. And so they're like, 4 models of iPhones that you can buy or even are supported, whereas there's like 1,000 or 2,000 models of Android. And Samsung must have 100 products that use Android, 100 different kind of phones, whereas Apple has 4, right? And so even though Android has an enormous market share, Apple is still able to hold the line in terms of profitability and effectiveness. But when the iPhone came out, it was around here, then Nokia wasn't doing wonderfully, but it was still a dominant player. And I was actually got to look at some of the earlier Nokia phones that tried to kind of mimic the iPhone, and it was awful. And we talked about the spinny thing on the iPod. All right, so on an iPhone, if you flick, right, the content scrolls, right? On this Nokia phone, they didn't do the engineering effort that Apple did, and when you flicked, it felt like you were moving stuff through mud, right? It just didn't feel right. It had this kind of annoying, I'm kind of stuck feeling compared to the iPhone, which is kind of fun and very responsive. So there were a variety of things about Nokia that they just did wrong in this early phase. And same with RIM, which is this orangey red line going down to 0 again, that they tried to come out with a full screen phone. I think it was called the Storm. Anybody try that? It was really awful as well. Yeah. Yeah. Nobody really liked it. And so, you know, a lot of people's attempt to copy this kind of style of interface without putting the sufficient effort into it or the resources ended up failing. Wake up. Oh, come on. There are also a bunch of, sorry, a bunch of, there are a bunch of examples of bad user interfaces actually killing people, which is pretty daunting. So this first one, it's kind of an old system, but it's still very informative. So this was a display for people on a ship for the Navy, and the people were supposed to track airplanes. And one of the key things that they were supposed to be able to determine was whether the airplane was going down or going up, right? Because if it was coming down at you, that was bad, right? But if it was going up, it probably wasn't bad, right? And so the way the Aegis system worked is it had a number here. And if the plane was coming down, then obviously the number would get smaller. And then it would, right? And if it was going up, well, then the number would get bigger, right? So that seemed like a perfectly reasonable interface. Well, what happened was the sailor who was supposed to be monitoring this misread one of these dots and thought it was coming down at them. And it was directly on a course towards the ship, and so they shot it out of the air. But it turned out it was a passenger plane that was actually taking off. It was indeed directly on a path to the ship, but it was going up, and because it was a passenger plane instead of going down. And this had been attributed to this user interface that the sailor, obviously it's a high stress situation, right? If you get it wrong and it's actually diving at you, then you know, it might blow you up, right? And so this is not a situation where they really are able to work at normal capacity. What might have been a different design that would have maybe been a better user interface? Yeah?
Color-coded it?
Sure, so it could have been color-coded. It might have been that this system was old enough that they didn't have that option, right? So what might be some other ideas?
Good flash if it was descending.
Right, so if you knew what the task was, if you knew they needed to detect descending, then you could say, well, let me make sure that that's really obvious and make it flash or somehow show specifically that this is one that you should pay special attention to. What else?
Just an arrow.
Right, so you could just have an arrow, easy to interpret, right? Show whether it's going up or down. Any other ideas?
I can show the ones going.
Right, why show the ones going up? I mean, maybe they needed to track everything for other things, but they certainly could have had modes, maybe, where it's, right, yeah. So, they could have had a mode where it said, oh, let me just show the ones that are coming at me, or they're coming down, and not show the ones that are going up, or whatever. Another possibility is there's no particular reason they needed the altitude. Maybe they should just show the change. So +3 or -700 or whatever, right? So if what you really need to know is the change, well, why not just show that? Why make people compute that in their head? Right? So that's the Aegeus one. There's a bunch of medical instruments which have been credited with performing poorly. This is a electronic medical record system, which when they put it in the hospital, slowed the doctors down so much that they actually started losing a lot more patients because the doctors were spending so much time doing paperwork on the computers instead of actually helping people. And this one, so we're coming up on election season. I hope you're all enjoying all the ads. This is from the election in 2000, which is a long time ago now. But if you remember, George W. Bush won that election over Al Gore. And the election came down entirely to how Florida voted. And there was all sorts of stuff about hanging chads and things like that. It turns out none of that was really relevant. The real thing that decided the election was a user interface error. That these are the ballots that were used in Florida. And there's plenty of evidence to show that, oops, what did it say?
Colors symbolizing up or down.
Yeah, color symbolizing up and down. Yeah, we said that. That's good. In this one, yeah, okay. So in this one, this was paper, and what the voters were supposed to do is punch out one of the black holes, and then it was read by a machine. Okay, and so you're only allowed to punch out one hole, and it was who you wanted to vote for president. And the Pat Buchanan. One of the things that was weird about the election, if you were up late watching TV, is that the exit polls showed that Gore had won by a landslide, and so a lot of the TV stations announced that Gore had won the election. But when they actually counted the ballots, they found that Gore had not won, but in fact there were thousands and thousands of votes for Pat Buchanan. So why is that? Right? Right, so you just, over here, I want to vote for Al Gore, so he's the second one, so I go over here and go down 2 and punch that hole out. All right, and so thousands of people punched this hole thinking they were getting Al Gore, but instead they voted for Pat Buchanan. So it's entirely a result of this user interface error that George Bush was president for 8 years. It's kind of funny, but also kind of not so funny. You probably heard about healthcare.gov a couple years ago when it came out. There were all sorts of software problems. Most of the problems in healthcare.gov were actually implementation errors. The engineering behind the scenes was really awful, but it's estimated that about 40% of the defects were actually user interface errors, that people were actually incorrectly using the site or weren't able to use it correctly. So why is this such a hard problem? Well, it turns out it's really hard to make things easy. And it's easy to make things hard, just kind of the way it goes. And another problem with user interfaces is once you get them right, it seems like that's really obvious, right? It's kind of like cleaning up your house, right? When it looks clean, it's like, okay, well, that's the way it's supposed to be. But no one really recognizes how much trouble it is to actually do all the cleaning. And it's the same way with user interfaces, that unfortunately we don't get credit for how much work it is to make things obvious. And until you've actually tried it, it's really seems like it should be easy to do the obvious thing, but it's really hard. User interface is a design problem, and so it requires creativity and skill. We talked about how it's hard to think like users, and here's an example. So if you've seen this before, don't say anything. If you see what's wrong with this, raise your hand. Okay? So most people don't see what's wrong with it. Now keep looking. There's something really dramatically and very easy to see that's wrong with this. So far, 80% of the people haven't seen it. Okay, now half. Okay, anybody still doesn't see it? Okay, it says a bird in the bush. Okay, right? Now everybody sees it. Okay, now pretend you don't see it anymore, right? And users are like this all the time. There's this giant button on the user interface, and you as a designer say, well, why didn't you push that button? It's right there in front of you. And it's kind of the same thing as here. It's right in front of you, but you didn't notice it, right? Somehow it didn't seem salient. It didn't seem important. And so this is kind of what happens with user interfaces. And it's kind of just an example of how it's hard to put yourself in the position of your users who don't know or see what you do. Specifications are always wrong. Designers are always telling me, oh, the marketing people will just tell me what to do and I'll do it, right? But that doesn't ever work, right? And so this iterative design process that we're talking about, the prototyping, is really required in order to really understand the real needs and avoid wasting all this effort. And unfortunately, the things we're trying to design are really complex. Originally, when we were designing the Macintosh, if you saw Steve Jobs' movie, Microsoft Word 1 had 100 commands. You know, Word, the current version of Word has, 3,000 commands? Something like that. The BMW iDrive, right? How many, in an old car, you had some buttons on the dashboard. There may be 20 things you could do. You can turn on the lights, right? On the iDrive, there are 700 things you can do with the console, right? It's just inherently harder to design 700 things as it is to design 20 things. And you can't necessarily copy other things because of the patent issues. And all design involves trade-offs, right? And so you're always going to be wondering, should I spend more money adding a new feature? Or should I fix software bugs? Or should I fix usability? Or should we just deliver it, right? And all of these are always trading off. And as a manager or a product lead or whatever, it's your job to try and figure out which of these makes the most sense. And you can't ever know that unless you know something about usability and are able to understand, how that fits into the whole picture. Okay, I'm not going to go through this part of the lecture. It's not that important since you guys aren't implementers. So we'll stop there. Feel free to look at this part if you're interested. And Wednesday's class will be downstairs in 1305 like usual. Everyone should fill out this chart. If you're planning to drop, that would be a good time to do it. If you like what you're seeing, then please stick around.